Today, we are rotating strings around, we are calculating Manhattan distances, we are counting nucleotides in a strand of DNA, we are pulling product details from a catalog, and then we calculate the variance of a sequence of numbers. Hello world, and this is Versus Codewars. And I hope everyone is having a wonderful and safe day today. We begin today's warm-up segment by merging two sorted arrays into one. We are given two sorted arrays, sorted in some order, be it ascending or descending, which only contain integers. The goal of this kata is to find a way to merge those two arrays into a single array, sorted in ascending order. Both arrays must be arrays with 0 or more integer elements, and if both arrays are empty, we just return an empty array. Now, these arrays, as I said before, may be sorted in different orders, be it ascending or descending. Also, these arrays may contain duplicate integers. We also have to make sure to remove those duplicates from the returned result. Alright, let's go ahead and get started with this one here. We're going to have our function here, const merge arrays. And we're going to have our first array and our second array. Now, what we're going to go ahead and do here, first let's go ahead and merge these arrays together. So we're going to do const merged array. And what we're going to go ahead and do is, we're going to go ahead and create a set here. We're actually going to go ahead and call this merge set, because we want to get rid of those duplicate elements. And we're going to create what is called a set. Now, in a set, unlike in an array, there can be no duplicate elements therein. So we're going in the set constructor, we're going to pass in an array here. And in this array, we're going to use the spread operator here to spread out the elements of our first and second arrays into this merged array here. We're going to do ... first array, and then ... second array. Alright, now that we have that, what we're going to go ahead and do, we're going to go ahead and return, we're going to do another array here, and we're going to spread out the elements of our merged set into a new array. Now, this resulting array will not contain any duplicate elements because any duplicate elements were removed when we created this set from the elements of our two arrays here. Now, we're going to take this resulting array and we're going to run it through the sort method. And for the sorting function, we're going to have our A and B here, and we're going to do A minus B to ensure that the elements of our merged array are sorted in ascending order. Alright, let's go ahead and punch this into Codewars to see what this looks like here. Alright, I'm going to go ahead and run these tests here. I'm going to hit attempt, and we are good on that. For our next warm-up kata, will we make it? We're camping with our friends far away from home, but when it's time to go back home, we come to the realization that our fuel is running out, and the nearest pump is 50 miles away. You know that on average, your car runs at about 25 miles per gallon, and there are 2 gallons left in the tank. All that considered, the goal of this kata is to write a function that tells you if it is possible to get to the pump or not. We'll return true if it is, false otherwise. Let's go ahead and hit train. Let's get started with this one. Alright, let's have a look at our arguments here. Const 0 fuel. And we're going to have 3 arguments here. Distance, the distance to the next pump, the miles per gallon, and the gallons left. I'm going to go ahead and zoom out here a little bit so we can see this whole thing here. The distance to the pump is how far to the next gas pump in miles. The miles per gallon, how many miles we can go on a single gallon of gas. And gallons left, how many gallons of gas we have left in our tank. So what we're going to go ahead and do, let's go ahead and
we're gonna do, I think it's
we can go ahead and calculate this by doing this. Now, we said 50 miles to the next pump, 25 miles per gallon, 2 gallons left. So, let's find out how many gallons it would take to get to the pump here. So, let's do constant gallons required. We're going to take our distance to the pump and divide that by our miles per gallon. And then we are going to return true if gallons left is greater than or equal to gallons required. Alright, let's see what this looks like here. Console.log, 0 fuel. We're going to pass in the parameters from the Kata instructions here. 50 miles to the nearest pump, 25 miles per gallon, 2 gallons remaining. Let's feed this into Node to see what this looks like here. Node warmup, make it. I'm going to zoom back out in here. And we get true for the result here. Let's have a look at some of the tests down here. What about 100 miles to the next pump, 50 miles per gallon, and 1 gallon of gas left? I expect to see false here, and we do. Alright, let's go ahead and punch this into Codewars to see what this looks like here. We're going to run these tests here, and we're going to hit attempt. And we are good on that. For our next warm-up kata, we are working on a function called Spacify, so that it returns a string with spaces inserted between each character. Let's go ahead and get started with this one here. Called Spacify. We're passing our string right here, and what we're going to do with that string, we're going to split it into its individual characters, and we are going to join that back together with a space separator. This ensures that there is a space between each and every character in the resulting string. Let's pass this into Codewars to see what this looks like here. And we are good on that. For our next warm-up kata, we are given another string. This time we have to swap the case for each of the letters. Let's go ahead and give this one a shot here. Any lowercase letter in the string becomes uppercase, and any uppercase letter in the string becomes lowercase. Alright, let's go ahead and do this. Const swap. Probably not a good name for the Kata solution function here. Anyway, we are going to go ahead and iterate over each character of the string here. I think actually what we're going to go ahead and do, we're going to take the string, split it into its individual characters, and run that through the reduce method. We're going to have our result and our char here. And we're going to set our initial accumulator to a blank string. And inside this predicate function here, what we're going to go ahead and do, we're going to do return result plus, and if char, actually what we're going to go ahead and do, if char is equal to char.to uppercase, we are going to go ahead and return result plus char.to lowercase. Otherwise, what we'll go ahead and do, we'll return result plus char.to uppercase right here. Let's test this out here with a string here. How about this Codewars string? Console.log swap. Pass in this Codewars string here, and we're do node warmup case swap. And as you can see, we get the characters of our string with their cases swapped. So this capital C up here becomes a lowercase c. And these lowercase letters in our string become uppercase. All right, let's go ahead and punch this into Codewars to see what this looks like here. Run these tests. And we are good on that. Finally, we are counting characters here. All right, we're going to be given a string here. And the goal of this kata is to make sure that each character in that string occurs the same exact number of times. And we will return true if it is in fact the case and false otherwise. All right, let's go ahead and get started with this one. For the case of this kata, capitals are considered the same as lowercase letters. In other words, case insensitive. All right, let's go ahead and give this one a shot here. Const validate word. We're gonna have our string here. And what we're gonna go ahead and do, I think we'll go ahead and keep track of an object here. Console.log, or rather, const letters, char occurrences rather. And then what we're going to go ahead and do with that, we're going to go ahead and iterate over each character of our string here. Char of string. And what we're going to go ahead and do with that, we're going to do char occurrences at char. I'm going to try a little trick here. We're going to do a ternary operation. And if a property with the key of this char here exists in our object here, we're going to go ahead and do this. Char occurrences at char plus plus. Otherwise, char occurrences at char equals 0. I'm going to go ahead and zoom out here just so you can see all that here. Maybe go ahead and do this for the sake of readability. Oops. I'm going to zoom all the way in here. If I'm right, what this should do here is check to see if there is a property in our char occurrences object with the key of this current character in a string. And if one such property is present, it will increment the numeric value of that property. Otherwise, it will go ahead and set that property to 0. All right, I'm going to go ahead and return our char occurrences here. And what we're going to go ahead and do, console.log, validate word. And what we're going to go ahead and do, we're going to maybe go ahead and do, let's pull one of these examples here. How about A, B, C, A, B, C, D? A string that should return false in our final kata solution here. Let's go ahead and console.log this to see what this looks like here. Node warmup char counter. And that is not what we want to see here. All right, let's see what's going on here. And that might not work the way we want it to work here. So what we're going to go ahead and do, if char occurrences at char is present in that object here, we're going to do char occurrences at char plus plus. Otherwise, we're going to go ahead and do char occurrences at char, and we'll set that equal to 0. Wait a minute. I think I just realized what was happening here. 0 is a falsy value in JavaScript. So, during our iterations, we would check to see if this was we were going to check to see if this is undefined. What we were actually doing here is we were checking to see if this was a falsy value. We were setting each of these to 0, 0 as a falsy value. So that's why this wasn't working. So what we actually need to do, we're going to do type of char occurrences at char. We're going to check to see if that is not undefined. All right, let's try that. And actually going to set this to 1 here. Oh, wait. Maybe we didn't need this after all. Yep, that works. Now, what we're going to go ahead and do, now that we know how many times each of our characters occurs in our string, what we're going to go ahead and do is we're going to go ahead and get each of the counts here. We're going to do counts, and we're going to set that equal to object.values. And we're going to pass in our char occurrences string. We're going to go ahead and return that for now. And we're going to console.log to see what that looks like. And this produces an array containing the values of each of the properties in our char occurrences object here. Alright, what we're going to go ahead and do with that, we are going to check to see if the minimum value of that counts array is equal to the maximum value of that array. And this should give us false in the particular case of this string here. The reason this returns false is, while there is one character in the string that occurs only once, while the other characters in the string occur twice. Now, if I were to get rid of this lowercase d here and run this, I would get true, because now the characters in the string occur exactly twice. Alright, let's go ahead and punch this into Codewars to see what this looks like here. I'm going to hit copy paste here. We're going to run these tests. And oh wait, case insensitive. So what we're going to go ahead and do, we need to take our string here and convert that to lowercase. Let's go ahead and copy this line to our Kata solution here. That takes care of that. And we are good. That concludes today's warm-up segment. I will see you in the next Kata. Here is a function that receives 2 strings and returns an integer, which is the number of characters we should shift the first string forward to match the second. The check should be case sensitive. For example, consider the strings fatigue and tigfa. In this particular case, the first string has been rotated 5 characters forward to produce the second string, so 5 would be the integer that is returned from the Kata solution in this particular case. If the second string is not a valid rotation of the first string, this Kata solution function should return -1. Alright, let's go ahead and get started with this one here. First, let's handle the edge case in which both of the strings passed in are equal. If first is equal to second, we return 0, because no rotations would be needed here. Now, what we're going to go ahead and do is, now, since we're outside of this edge case here, we know we're going to need at least 1 rotation. So we're going to do let rotation count equal 1. And then we're going to do let rotated characters, rotated chars equal the characters of our first array. We're going to take these rotated chars, and we are going to push the return of rotated chars.shift. Now, what this is going to do, this is going to pop the first character from our rotated chars array, and then push that character to the end of that very same array. Let's go ahead and console.log this to see what this looks like here. Console.log rotated chars.join. We're going to join that together with a blank string separator here. Let's run this through Node to see what this looks like here. Node calculate string rotation. And we have an error here. What's going on? Rotated chars. Let's try that again here. And we have the string fatigue f. That is the characters of the string fatigue with the first character rotated to the end of the string. Alright. Now it... No, I am actually approaching this wrong here. In that particular case, we were actually shifting the characters back. What we actually need to do is rotated chars.unshift rotated chars.pop. So what this is actually doing is popping the last character from our rotated chars and then inserting it at the beginning of the rotated chars array. Let's actually log that to see what that looks like. And note here that the E, which is normally at the end of fatigue, has been removed from the end of the string and inserted at the beginning. Now, what we need to do is we need to repeat this for each iteration of our array. So what actually we are going to go ahead and do here, I think we're going to try a while loop here. I think it's a while. Rotated chars.join blank string separator is not equal to the first string. And then what we're going to go ahead and do, we're going to go ahead and repeat this in our while loop here. And then we're going to go ahead and iterate our rotation count. And then we're going to go ahead and check to see if our rotated chars.join blank string separator is equal to our second string, in which case we will return our rotation count. Otherwise, if we reach the end of this while loop without that happening, we'll return -1 instead. Let's try this out here. And we do get 5 rotations here. I just wonder, though, if there is a better way we could approach this here, because we're calling the join method twice here. I have a feeling that isn't quite necessary here. Or maybe it is. Alright, anyway, let's go ahead and test this out here. How about moose and moose? I expect to see -1 here, and we do. How about some coffee here? EECOFF, E cough, and then coffee. This should return 4 rotations, and it does. Alright, let's go ahead and punch this into Codewars to see what this looks like here. Let's run these tests here. Then let's hit attempt. And we have a problem. What is going on here? Oh, that's interesting. Alright, let's go ahead and copy these strings into our local solution here. This looks like an interesting case. Where only 1 rotation would be needed for the first string to match the second. And I think I know where we're going wrong here. I think we need to do our check here first. And then we do the shift. I think that is where we were going wrong here. I do have a little bit of an optimization in mind here. While we get rid of this, set our rotation count to 0. We might not need this edge case up here. Let's see what that looks like here. We get -1 for that, and we don't want that. Ah, yeah. So this is gonna need to be a do while loop here. And we get our 1 here. Let's go ahead and revisit that coffee example down here. Just to make sure that this one is still working here. I expect to see 4 characters, and we do. Alright, let's go ahead and punch this into Codewars to see what this looks like here. Alright, let's run those tests here. And we are good. Here is the better code solution of the day. Pay mind to the code snippet you see below me here. Now, why go through all of the hullabaloo I went through in implementing my Kata solution when you can go this simple route right here? First, check to see if the lengths of the 2 strings are the same. If they are not, we return -1. Next, we take the second string, concatenate it with itself, and then we run that resulting string through the index of method. Now, you've seen me use the index of method to look for the first and the last instances of characters in a string. The same method can also be used to look for the first instance of a substring within a string. The substring in this case being the first string that we pass in. Now, if this substring here is not found in our concatenated string, we go ahead and return -1. Otherwise, this method will return the index of that substring in the concatenated string, which just so happens to be the number of rotations we would need for the first character to be able to match the second. The distance formula can be used to find the distance between 2 points. However, what if we were trying to walk from point A to point B, but there were buildings in the way, large skyscrapers? The kind of skyscrapers you would find in a big city, like, say, Manhattan. Well, there just happens to be a distance for that. The Manhattan distance is the distance between 2 points in a grid, like the grid-like street geography of the New York borough of Manhattan, calculated by only taking a vertical and/or horizontal path. Here is a function that accepts 2 points represented by 2 pairs, hence these 2 arrays right here, and returns the Manhattan distance between these 2 points. The points are arrays or tuples, pairs, containing the x and y coordinates in the grid. You can think of x as the row and y as the column. Alright, the goal, as I mentioned, is to return the Manhattan distance between these 2 points. Let's go ahead and get started with that here. Alright. I'll point you to these examples right here on the Kata instructions here. Now, what we're going to go ahead and do, I think we'll go ahead and keep track of a distance here. Const. We're going to do a destructuring. Yeah, distance. We're going to set that equal to 0 and a 0. And I think we're going to do a while loop here. We're going to do while ax is not equal to bx, and, or rather, ay is not equal to by. So this while loop would continue as long as these x coordinates here are different or these y coordinates are different here. And at the end of this while loop, we're going to return that distance here. Alright, what I think we're going to go ahead and do. By the way, this first element of our distance array is going to be the x, and the second our y here, if you haven't taken that away yet. Alright, what we're going to go ahead and do, I think we're going to make use of a couple of if blocks here. If ax is less than bx, then ax plus equals 1, and then distance at 0 plus equals 1. Or rather, we'll just go ahead and do plus plus here. And then else if ax is greater than bx, ax minus minus, and distance at 0 plus plus. And then we will repeat that for our y coordinate here. And I'm going to take these here. Take the x in our selection here. Or maybe not. Okay, we'll just go ahead and do it the old-fashioned way here. Take these x's here and replace them with y's. And then distance at index 1 here. Alright, this should do it. Let's go ahead and console.log some examples here. Console.log Manhattan distance. We're going to pass in a couple of pairs of 1s here. Alright, let's punch this into node to see what this looks like here. Node Manhattan distance. And we get our pair 0, 0. Alright, let's try another couple pairs here. 5 and 4. And then 3 and 2. And I am approaching this wrong here. We actually need to return a single number here. So what we're actually going to go ahead and do, actually instead of const distance, we're going to let distance equals 0. And then we're going to go ahead and take all these here. And then actually what we can go ahead and do, we can go ahead and take all of these out here, because this particular line of code would be redundant when we can just go ahead and increment that at the end of our while loop here. Or maybe not. Yeah, or maybe not. Yeah, I know there's probably an optimization that can be made here. So what we're actually going to go ahead and do, if ax is not equal to bx, we're going to encompass this whole if block here inside here. Get rid of this distance plus plus here and move this distance plus plus to the end of this particular if statement here. And then here we'll do if ay is not equal to by. I'm going to move all this up here. Get rid of this distance plus plus and move this down here. And this should give us the same result here. Alright, let's try one more pair of pairs here. 1 and 1, and then 0 and 3. And we get 3 as the result. Alright, I think I'm feeling good about this. Let's punch this into Codewars to see what this looks like here. And we are good. Now, a couple of things with this Kata solution. First, what is with the parameters in the Kata solution function here? Well, if you are writing a function that accepts an array or an object as a parameter, what you can do is you can pull specific elements or properties out of that object right in the parameters by doing a little destructuring here. You noticed a couple of array destructurings in our parameters here. The first pair we were pulling the x and y coordinate from the first pair, and then we were pulling the x and y coordinate directly out of the second pair in this particular destructuring example here. Second of all, there is an easier way to approach this than what I did here. What you can do is you can take the x coordinates from the first and second points, subtract them, and then calculate the absolute value of the difference. And then repeat that for the y coordinates of the 2 points as well. And then you can take the absolute values of the differences and then add them together to get the Manhattan distance between the 2 points. Here is a function which accepts a string with characters representing nucleotides in a strand of DNA. The goal of this kata is to count the number of times these nucleotides, A for adenine, C for cytosine, G for guanine, and T for thymine, appears, and return those occurrences in an object. Alright, let's go ahead and see what that looks like here in the kata instructions here. Here we have the string ACCGGT, and we are supposed to return an object with each of occurrence of those nucleotides. Now, if I'm not mistaken, this should be case insensitive here. Let's go ahead and give this one a try here. What we're going to go ahead and do, we're going to go ahead and create an object here, const nucleotides, and we're going to go ahead and create an object here with the following properties: A, C, G, and T. And we're going to set each of these to 0 to start. And we're going to go ahead and return this object here. Now, what we're going to go ahead and do, we are going to go ahead and iterate over the characters in this genetic code right here. I'm going to have a look at some of the tests here. Yeah. All right, what we're going to go ahead and do, we're going to do for const char of genetic code, and we're going to go ahead and transform this to uppercase here. Now, what we are going to go ahead and do, if in the event that this genetic code contains an invalid nucleotide, we're going to go ahead and null check that here. If type of nucleotides at char is not equal to undefined, then we are going to go ahead and do nucleotides at char ++. And that should be all there is to it. Let's go ahead and take that aforementioned string up here and test this out. Console.log get counted nucleotides, and we're going to pass in this string right here. Let's go ahead and feed this into Node to see what this looks like. Counting DNA. And as you can see, we get an object here that tells us how many nucleotides are in this strand of DNA. We have 1 adenine, we have 2 cytosine, we have 2 guanine, and we have 1 thymine. Alright, let's go ahead and punch this into Codewars to see what this looks like. Let's have a look at this example here. Yeah. Alright, let's go ahead and hit test and hit attempt. And we are good. Not really much to say about this kata solution here, so in lieu of a reflection, I just thought of another way I could implement this kata solution using the reduce method. So, what we're going to go ahead and do, we're going to do this again. Instead this time, what we're going to go ahead and do, we're going to do return ... genetic code. We're going to split this into its individual characters here. Again, we're going to go ahead and transform all this into uppercase. And then what we're going to go ahead and do, we're going to run this through the reduce method. And we're going to have our nucleotides here for our accumulator and our char here. And what we're going to go ahead and do, we're going to set our initial accumulator to an object here with our aforementioned A, C, G, and T here. And what we're going to go ahead and do, we're going to go ahead and we're going to go into this function here. We're going to go ahead and do if type of nucleotides at the current char is not undefined. We are going to go ahead and return our nucleotides object here, spread out into a new object. And then what we're going to go ahead and do, we're going to do a little bit of a trick in deducing the key of the object whose value will change in this iteration of reduce. What I'm going to go ahead and try doing, in this bracket here, I'm going to do a char, and then I think what I'm going to go ahead and do is nucleotides at char plus 1. And then, otherwise, if this is undefined, we'll just go ahead and return our nucleotides object here. Let's go ahead and punch this into node to see what this looks like. Again, I've got this same string down here. And we have undefined, 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 undefined. That's not what we want to see here. Why are we getting that? Let's go ahead and console.log nucleotides. Oh, right. Doing the +1 inside the bracket there. And we do get that same result here. 1 adenine, 2 cytosine, 2 guanine, and 1 thymine. Alright, let's go ahead and get rid of this console.log. Let's punch this into Codewars to see what this looks like. Copy, I'm going to paste this into Codewars here. I'm going to run the test and those pass. And I'm going to hit attempt, and we are good on that as well. I will see you in the next kata. Here is a small XML style extract of a catalog here. Now, this extract here contains some details on several different products here. Each of these details are encapsulated in a prod tag representing the product itself. The name of the product is contained within these name tags right here. The price is encapsulated inside these PRX tags, and the quantity within these QTY tags. What we are going to do with this extract here is we are going to look for products whose name fully or partly matches the article that we pass in to the Kata solution up here as the second argument here. We are going to take any of the products that match here, and we are going to map those out into a new line separated string that looks something like what you see here in the Kata instructions here. For example, consider the table saw product. We have the name of the product here, and then a greater than sign. Then we have the price, which will be specified in dollars, and then the quantity. And then for each match, we are going to repeat this, and each match will be separated by a new line character. Now, if the article specified in the second parameter does not show up in our catalog snippet, then we should return a string called nothing. Now, there's a blank line between 2 lines of the catalog. The same article may appear more than once. If that happens, return all the lines concerned by the article in the same order as in the catalog. The line separator of results may depend on the language. We're going to use the new line character because we're using JavaScript. Alright, let's go ahead and give this one a try here. Alright, I have the function here called catalog, which will take our snippet right here as the first argument, and the article we are looking for as the second one. Now, we know that the product name will be encapsulated in this table saw right here. Now, let's have a look at some of the sample tests here. There's a lot of products here. Anyway. All right, what we're going to go ahead and do, let's go ahead and I think we are going to be using some regular expressions here. So what I think I'm going to go ahead and try doing, Alright, we'll do a regular expression for our article here. Article regex. We're going to actually use the regular expression constructor here. We're going to pass in the article here. And then we're going to use the global flag here. Now, I explained, I think a couple episodes of Versus Codewars ago, that if you use the G flag in a regular expression, it keeps track of an internal last index here. That will keep track, and it will start matching to the string starting at that particular index in the string. So what I think we should be able to do here is, I think it's test. While article regex.test, and we're going to pass in our snippet here is equal to true. This should return here, if I am not mistaken. I'm going to go ahead and console.log article regex.lastIndex. That aforementioned last index I was talking about. Let's go ahead and feed this in a node to see what this looks like. Node catalog. And we do have, this gives us the indices of the parts of the string, the substrings that match up with our regular expression here. We should be able to use that to determine where the product tags are here. Alright, with that being said, let's go ahead and give that a try here. First, let's grab that last index here. And then what we'll go ahead and do, we're going to go ahead and look for the last instance of the prod tag from that point, and then the first before that point, and then the first instance of the closing product tag after that point. So const opening prod tag. We're going to set that equal to snippet.lastIndex of. We're going to pass in the opening prod tag. And then we're going to go ahead and pass in that last index here. Similarly, what we're going to go ahead and do is going to do const closing prod tag. We're going to set that equal to snippet.index of the closing prod tag at that last, from that last index. I'm going to go ahead and console.log those to see what those look like. Opening prod tag and then closing prod tag. I'm going to go ahead and run that through Node to see what that looks like. And that should give us the positions, the indices of the opening and closing prod tags encapsulating the substring that matched our regular expression here. And what we should be able to do with that is const product string. We're going to do snippet dot, I think it's substr substring. And then we're going to pass in the opening prod tag and then the closing prod tag. Let's console.log that to see what that looks like here. Alright, and that does... I think we could just... Yeah. I think from here we can go ahead and try extracting our strings here. And I think there are some other regular expressions that we can use to achieve that end. Let me go ahead and... Yeah, okay. What we'll go ahead and do. Const name of regex. We'll set that equal to... name, and then we'll go ahead and in a capture group here, I think it's W plus here. Why is it complaining here? Variable declaration expected. Unterminated regular expression literal. Oh, right. That needed to be a backslash here. All right, let's go ahead and use this regular expression here to extract the name of our regular expression here. I'm going to do console.log product, or rather, name regex.exec. We're pass in our product string. Let's see what this looks like here. No, undefined. That's not what we want to see here. Or maybe, do we need the global flag here? Yeah, that ain't gonna do it either. So, alright, let's go ahead and console.log that product string again. And let's just go ahead and review that. Alright, I have a new idea here. Maybe, perhaps. Let's actually go ahead and get the indices of the name, price, and quantity tags. Const, okay, closing, opening, name tag. And we'll set that equal to product string dot index of name here. Const closing name tag equals product string dot index of the closing name tag. And starting from the opening name tag here. Alright, we're going to go ahead and repeat that. Whoops. We're going to go ahead and, excuse me. We're going to go ahead and repeat that with the price tag. And then we are going to go ahead and repeat that with the quantity tag. QTY. Whoops. Why did I... whoops, hold on one second. Yeah, let me get everything all set up here. QTY, QTY. Then we're going to go ahead and change this to quantity. Alright, now what we're going to go ahead and do. We're going to go ahead and get the name, and we're going to go ahead and do that by doing this. Product string dot substring opening name tag plus 1, 2, 3, 4, 5, 6 plus the 6 characters in the opening name tag string, and then we're going to substring all the way to closing name tag, the first character of the closing name tag. All right, we're going to repeat that for the price. Product string dot substring opening price tag plus 1, 2, 3, 4, 5, the 5 characters in the price tag string, and then closing price tag here. We're going to substring to that, and then finally we're going to repeat that for the quantity here. Product string dot substring opening quantity tag plus, again, 5 characters, and then substring to the closing quantity tag right here. Let's go ahead and take all that and console.log it. Name, price, quantity. And let's run that through Node to see what that looks like. We have an error here. Product string is not defined. Because I misspelled product string. I'm going to copy, paste, paste, paste. All right, let's try that. Let's clear the terminal and let's try that again here. And as you see, again, the name of our product, the table saw, the price, about 1,100 bucks, and 5 table saws here. Now, what we can go ahead and do with that, according to the Kata instructions here, we need to format this as such right here. And we're going to use an array right here, const products. Set that to an empty array. And at the end of this while loop, we're going to do products.push. And we're going to use a template string here. First, in the first placeholder, we're going to have our name. And then we'll have the greater than sign here. And then the PRX. We're going to have our price in here. And then the quantity, we'll have our quantity right here. Now, at the end of this loop here, what we need to do, we need to check to see if our products array has anything in it. We're going to check to see if our products.length is equal to 0. If it is, we'll return the string nothing. Otherwise, we'll take our products array and join that together with a new line separator here. All right, let's run that through Node. And we have another problem here. Products is not defined because, once again, I misspelled products. And we have another problem. And again, we misspelled products. Now we have our matched products formatted in the string that the Kata solution has called for. All right, let's go ahead and punch this into Codewars to see what this looks like here. We're going to run these tests here. And we have a problem here. Okay, let's go ahead and take this whole thing here and copy this into our Kata solution here. Now let's run this through Node here. Alright, we have our table saw. Price at $10.99. Quantity of 5. Alright, new line. Saw. Price 9, quantity 10, new line. Saw for metal. Oh! Okay, we actually need to have a new line and carriage turn as well. Alright, let's go ahead and fix that up right here. And we are good. Now, this was a very interesting kata, and I had a lot of fun with this one. What I was initially going to do was use regular expressions to pull the name, the price, and the quantity from their respective tags in the matched product string. I was going for instance, to grab the name, use a regular expression that picked up the opening name tag, and then a capture group that looked for any letters, any number of letters within the opening and closing name tags here, followed by, of course, the closing name tag. I was going for that, unfortunately, to no avail. As it turns out, where I was going wrong was, I was actually using the /W, and that actually looks for anything that's not a letter. I should have used the /w to look for letters, and /s to look for white space as well. What I ultimately wound up doing was using the index of, last index of, and substring methods to pull those details out from those tags. In any event, I'm actually kind of satisfied with my Kata solution here, but I could always look for improvements too. Here is a function that takes an array of numbers and calculates what is known as the variance for that sequence of numbers. The variance for a sequence of numbers is found by subtracting the mean from every value, that is the average from every value, squaring the differences, and then adding those all up and then dividing by the number of numbers in that sequence. Alright, let's go ahead and get started with this one here. Alright, first we need to calculate the mean of our numbers here. So we'll do constant average. We're going to take our numbers, reduce, we're going to sum all of them up. And then we're going to go ahead and divide that by the length. By the way, since we're dealing with division here, we need to check the length of our numbers here. And if it's 0, we just return 0 up here. Alright, what we're going to go ahead and do, we're going to keep track of a result here. We're going to go ahead and iterate over, or rather, we're going to do another reduce call here. We're doing return, reduce, we're doing rather numbers, not reduce. We're going to do another call to reduce here. We're going to have our accumulator and our value. And what we're going to go ahead and do with that is, we are going to go ahead and take our value here, subtract the average, and then we're going to raise that to the power of 2 here. We're going to... And then, once again, we are going to divide by the number of elements in the array here. Alright, let's go ahead and test this out here. Got some arrays down here that we can go ahead and put to use here. Copy those from the tests. And of course, since I don't like var, I'm going to replace those with const. And what we're going to go ahead and do down here, console.log, we're going to put these numbers, or number arrays, into its own array here. And we're going to run that through the map method, and we're going to pass each of those through our Kata solution function here. All right, let's feed this to node and see what this will look like. Node calculate variance. Oops. And we should have the variances of our numbers here. All right, let's see what these tests look like here. And something does not seem right here. Okay, let's go ahead and look at this again here. All right, let's go ahead and do this here. Console.log variance. We're going to pass in an array 1, 2, 2, and 3. Let's feed this in a node and see what that looks like here. And we have 0.5 for that variance here. And that's what we want to see here. How about the array -10, 0, 10, 20, 30. And we get a variance of 118. So we take first we put all these together and then calculate the average. So -10, 0, -10, 0, 20, 50. 50 divided by 5 is 10. Okay, then we'll take the average. -10 plus. I think this is it. Let's see here. No, I think the order of operations would take over here. What about the array 8, 9, 10, 11, and 12? We'd have a variance of 2.8. Now, our tests here run these variances through the toFixed method. So let's call that here on the result here. And we get 2.8000. And that's going to give us a little problem here. Alright, let's go ahead and punch this into Codewars to see what this looks like here. I expect, unfortunately, to see some errors here. And we do. Alright, let's run through these instructions again. Variance for a set of numbers is found by subtracting the mean from every value. So we calculate the average here first. Let's go ahead and console.log that here. 9, 17, 27, 38, 50. 50 divided by 5 is 10. And then we take each element, subtract the mean from those values, and then raise the difference to the power of 2. And then we divide all of that by the number of elements. Oh, okay. Yeah. Oh, what? Now, was this ever an experience here? I don't think I have ever run across this before. But what was happening here was, for whatever reason, the predicate function of our reduce method was ignoring the first element of our array. And the reason that was happening was because I was not specifying a default accumulator right here. I have never run across that before. I certainly will have to remember that going forward. Alright, let's go ahead and run these other tests here. 8, 9, 10, 11, 12. I'm going to run that through node here. And that's given us the correct variance of 2. And let's run through this bottommost one here. 1.5, 2.5, 4, 2, 1, 1. And this one gives us the variance of 1.0833. And that is correct here. Alright. Let's go ahead and punch this into Codewars to see what this looks like. And we are good. So, why was our calls to the reduce method ignoring the first element of our numbers array? Well, it was because we did not specify an initial value for our accumulator here. And the reduce method, if no initial accumulator is provided, will set the initial accumulator to the first element of our array. That would have been fine in our first call to reduce when we were calculating the average value of the elements in our array. But that led us to a lot of problems when we were going to calculate the variance of the numbers in our array here. Because the first element was being set as the initial accumulator because we had failed to provide a default accumulator value here. And we needed to access that first element of our array so we could subtract the average from that element and then raise the difference to the second power. That's what was causing a lot of our headaches in this Kata solution. Glad I was able to figure it out though. I will include the documentation on the reduce method from MDN in the description box below if you would like to have a look. And that is going to do it for today's episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars. As always, if you think there is anything I can do to improve on my code for the better, feel free to drop a suggestion in the comment section below. Also, if you are an author on Codewars and you would like to share your authored katas with me, feel free to drop links to those katas in the comment section below as well, and you might see me take on some of those katas in a future episode of Versus Codewars. I hope you have a wonderful and safe day, and I will see you on the next episode of Versus Codewars.